Hello YouTube, this is Dylan. As I'll be using Intel for this ITX PC build, I've chosen to go with the Asus Strix Z790 iGaming Wi-Fi motherboard. It supports LGA 1700 socket, which consists of Intel CPUs from 12 to 14 Gen, DDR5 memory and has PCIe 5 with onboard Wi-Fi 6E. I decided to go with Asus since the last PC I had lasted 10 years using their motherboard. I picked the i7-13700K for the CPU since this PC is going to be used mainly for video editing on Davinci Resolve and some photography editing work. I bought this off Amazon, supposedly new, though clearly you can see it suffered some abuse along the way. The seal was very easily bypassed, which defeated its purpose, and now I just hope it works without any problem. The problem with buying off Amazon is that you risk getting products that were used for reviews and they are new since they were not used. In my opinion, this plastic case should be sealed to ensure what we receive is indeed a new product. Well, as you can see, it is not the case, but on physical inspection, it seemed to be in perfect shape. Seating the CPU is not the hardest thing to do, but it is important you do so with care for the little fragile socket pins and also align the groove on the side of the CPU with your socket. For the DDR5 memory, I chose the Corsair Vengeance 64GB kit at 6000 MHz with RGB because there was a shortage at the time of purchase and I took whichever I could get my hands on. Take a look at the seal quality between the two packaging. Corsair has definitely done it right, as you can be sure that in order to remove the RAM, one would have to break the seal. I bought them at Corsair's online store, though initially I wanted to get the Dominator series in white, but in the end I am happy with this Black Vengeance kit. Since my last PC was using the Vengeance DDR3 LPX, I put my faith on Corsair for this build. Much like the CPU, there is a direction for the seating of the memory and you will be guided by a groove in the memory slot. You should hear a distinct click when it's done properly. The motherboard has two NVMe slots sandwiched together with an integrated heatsink. Since the secondary NVMe drive slot is PCIe 4.0, I decided to go with the Crucial P3 Plus 4TB drive. By unscrewing a few screws, you remove the heatsink module, which reveals the bottom M.2 slot, which is written PCIe 4.0. You will need to add this little rubber pad included in the Asus motherboard package to support the single-sided P3+. After which, you slot the drive in and lock it in place with the lever on the motherboard. Here you see that little rubber pad serves to provide contact to the heatsink, and although it looks like the drive is warped, it is absolutely fine. The most important part is to remove the sticker on the thermal pads to ensure the proper heat dissipation, and in this case, I recommend choosing a single-sided drive for the M.2 slot since there's no thermal pad under. However, the top M.1 slot can support two-sided NVMe since it has two thermal pads. Unfortunately, I lost some footage for this part of the installation due to the fact that my parcels from Amazon were stolen, which I had to record the process at a different time, and my camera failed while rushing the assembly of the PC in order to test the parts. In any case, I used the single-sided Crucial P5 plus 2TB drive on the M2 slot for Windows and programs, as is faster than the P3 Plus. Storage is one of the area in PC building where you can save a little, but you must go with a reliable manufacturer. We are using the Noctua NH-D12L for cooling the processor. It features a 5 heat pipe dual tower design and a round frame 120mm PWM classic brown fan. It comes with all the necessary mounting accessories for Intel and AMD, as well as the NTH1 thermal paste. However, I feel that the naming of the cooler can be improved because 120mm is the fan size, not the tower height, which is in fact 145mm. Despite that, this NH-D12L allows us to have the right clearance to use the NR200p tempered glass panel without any mods. I'm really glad that Noctua came out with the solution that is compatible with the NR200p right out of the box. As this is the first time I buy a Noctua product, I am impressed by the packaging and the build quality of the parts. Unfortunately, at the time of this video, there isn't any Chromax black version to match the build, which I hope Noctua can consider this option in the future. If this is the first time handling the cooler, be careful not to cut yourself by these sharp aluminium fins. There is also no shame in referring to the handy manuals included by Noctua. In our case, for the LGA 1700 socket, we are going to use the number 2 position for the Securefirm 2 backplate. Securing these little fasteners require a little dexterity if you are doing this for the first time, and I would recommend doing this in a bright and uncluttered space. In order for you to imagine how frustrating and annoying these little buggers are, it is why you are spending 10 seconds watching me struggle and not 2 hours hunting for them in your room. And after that long fight, we can finally insert the backplate onto the motherboard. Next, these little blue spaces have to be inserted before mounting the brackets for the cooler. Keep in mind we are using hole position 2 and finally securing the brackets using the crisscross method with the provided screws. I don't remember when or how I've gotten this long magnetic screwdriver, but it is incredibly useful for PC building. This bracket determines the contact between your tower cooler and the processor, so it is important not to over tighten the screws. The ITX case we are using today is the white NR200p from Coolermaster, and I really like the quality and the price of the case. The front panel has two USB 3.1 Gen 1 ports, the power and the reset button, as well as the 3.5mm audio jack, which, spoiler warning, our motherboard was not able to support. There are a bunch of accessories that comes with the case, but first let's take apart the mounting frame for the side case fans. We have the instructions manual and the box containing all the accessories, including the Gen 3 PCIe riser cable and two Sikaflow 120mm case fans. However, I replaced them with Noctua's A12's Pro Max instead to ensure I get the best performance in noise and efficiency. It is my first time unboxing them. They truly look and feel impressive. The anti-vibration pads are swappable with 6 default colors to match your build. For this build, I will be swapping them for the white ones to match my white PC case. Coolermaster did include its Y cable to daisy chain your case fans, which you could use, though in my case, my fan header on the motherboard is close to the top of the case and using only 2 fans, the Noctua Y cable is a shorter run which improves my cable management. To avoid any potential void in warranty, I recommend that if you are using Noctua fans, you use Noctua's cables. It's very cool for Coolermaster to include their fan guards for their Seeker Flow fans, which in a tight ITX case, you wouldn't want cables to go into the fans. You may choose to install them on the Noctua fans if you want, but for my build, I'm only taking the mounting screws. Installing the case fans is very easy. Thanks to the brilliant design, you only need to push the mounting screws in place. Going with the Corsair SF750, let's get the PSU cage out from the case for the installation. You can technically just remove the side panel for the PSU installation, but I recommend taking it all apart since you'll need to for cable management. The SF750 is Corsair's high-performing ITX modular PSU rated at 80+ Platinum. It is sufficient according to the PC Builder 2 on PC Parts Picker, which by the way is a great site. Whether you're a veteran PC builder or new to the game, I highly recommend the tool for an initial compatibility check before referring to the manuals for the technical specifications. Like many other manufacturers, Corsair included their sticker for those who believes that a finished build is one with stickers on their case. Whenever possible, I recommend hand tightening the screws first before using the screwdriver, allowing more precision and reduces the risk of over-tightening the screw, or even worse, damaging the screw head. Trust me, because I'm not selling you any screwdriver set yet. Always use the crisscross method to ensure all the screws are aligned before finishing the tightening process. My preferred method is to do an anti-clockwise turn until you feel the screw is in the groove before you turn in clockwise to drive it in. Finally, you hook the PSU cage back to the case and secure it with the 2 screws. For cable management is mainly the 24-pin socket for the motherboard, the CPU socket, some front I/O cables, and the GPU cables. You will have to see where you can route and hide them as the headers and sockets are located differently with each motherboard. After this first ITX experience, my advice is to take out these pin covers carefully before mounting your motherboard. Also, in order to accommodate the 2 SATA port on the FPS 2 card on the motherboard, I had to make a small cut on the PSU bracket using the Dremel. This step is important for connecting up to 2 additional SSDs under the front panel of the case. We are using the 4TB MX500 from Crucial. Not sponsored by the way, I just prefer to use matching brands so it's easier to install drivers and update my firmware. Attaching the SSD is really easy, much like our case fans, thanks to these rubber grommets. As mentioned earlier, the front panel audio port is not supported on the Z790 iGaming Wi-Fi, but it does come with the Asus Hive, which has a ton of features on top of the audio jack. Like having the quick BIOS update port or an extra USB-C, a volume control knob and some other buttons which can be customized to reset your system, turn Aura on and off, or boot directly into BIOS. It is also magnetic, so you can stick it on your case or wherever possible. The NR200P supports GPU up to 3 slots, which in our build, we are using the Asus ROG Strix 3080 White, which is a 2.5 slot card to match with our 1300K processor. I must say that these days GPUs are kind of massive, but thankfully the structure of the NR200P can be dismantled to help with the installation. One tip I can offer you is not to forget peeling off the plastic protective stickers on the card before mounting it on the motherboard. There are also some dust covers which are included with the 3080 for your unused spots. They are great, but you will need to remove one of them in order to fit the card in. With that being said, by aligning the card straight and a bit of firm pressure, your graphics card should lock in place with a click. Finally, we are using the included Noctua NTH1, and this is the part where you have to take care not to over apply the thermal paste. I am showing the recommended method by the instructions manual, but the general P-size method should be fine too. Mounting the cooler is one of the more sensitive part of the process, but thankfully with high quality coolers, you will have these spring-loaded screws that reduces the chances of over-tightening and uneven mounting pressure. Attaching the CPU fan is the last part before we secure the fan cable to the CPU fan header on the motherboard. Thank you for sitting through 17 minutes of my video, and now let's boot our system into BIOS. Go into advanced mode, check and ensure you're on the latest BIOS version for your processor. Our motherboard has Memtest86 built in, which is a utility for checking your computer's memory, and I recommend running it once at memory non-XMP settings to check for errors. Memtest86 takes time, and you'll be greeted by this beautiful green pass if you are lucky. Our Asus motherboard is also able to save up to 3 reports within the BIOS, and note that you can run Memtest86 via a thumb drive if your motherboard doesn't have this feature. In this part of the video, I will show you all the settings I've made on this system. I was able to run our DDR5 64GB kit at 6000MHz stable under factory defaults XMP2. As for the CPU undervolting, I will put a link in the description to the better explained video by Marcus Aurelius, and I will highlight only the key setting I have changed which work for my system. And that is, I have changed the offset voltage to 0.05 instead of 0.1 in Marcus's video. XMP wise, I have to manually lock my memory controller voltage at 1.35 volts, which is by right set automatically by the XMP profile. Another important setting to check in the BIOS is to ensure your PCIe bandwidth is working at X16. Now these are hardware dependent settings, which G5 means Gen 5. In my system, our components are all Gen 4, so there's no potential bandwidth problems. However, should you decide to upgrade in the future to Gen 5 components like the GPU or the M2 NVMe, do note that the bandwidth will be reduced if both are Gen 5. In order to ensure you get X16 bandwidth, you'll have to go under onboard devices configuration to change this PCIe bandwidth bifurcation configuration from auto to X16. Next is about Q fan control, which I had to use a more aggressive fan curve as I'm using the tempered glass panel for my NR200P with only 2 Noctua case fans. Depending on your setup, adjust accordingly to find the balance between performance versus the noise level you can accept. In my case, I want to prevent the sudden ramp up in fan speed, so I maintain the fans at 50% from the start. Once you are satisfied with your settings, remember to save your profile, which I highly recommend you to note them on paper as well. That's because you will lose them should you reset your CMOS, which is useful to fix a buggy system after too many BIOS adjustments. To stress test the system, you will need to install some free tools, which I will put up here on the screen, as well as some download links in the description. On screen now is the HWinfo64, which is useful to monitor your system temperature during the test. In general, the temperature of your components should be around 40 degrees Celsius on idle or low load conditions. Our first stress test is the Intel XTU benchmark, which is only for Intel processors. Please feel free to share in the comments the equivalent program you use for AMD system. What is good with this utility is that you can upload the results to the HWBot site for a free analysis and see how you fare against others with the same processor. Thankfully, our system survived XTU. You can see that our system throttled at 90 degrees Celsius due to our undervolt settings and also information like power draw, etc. Next, we'll run Cinebench R23 to further test our 13700K on its multi-core and single-core performance. The objective of this test isn't about the numbers or ranking, but about achieving system stability. Should your system crashes while performing any of these tests, you will have to review your system settings. By the way, you will see your CPU hovering at higher temperatures as you perform these tests. This is normal and it will be resolved once we find stability. Heaven 4.0 is great for testing your rig, especially on your GPU. As we have undervoted our 3080, you can see that it was able to stay at 63 degrees Celsius while working at 100% with voltage locking at 0.975 volt. Also, you may have noticed I'm testing on Extreme 1080p as unfortunately I haven't decided on a better monitor for my system yet. To undervote your GPU, you will need to use MSI Afterburner, and Optimum Tech has already a great video on this, which I will leave a link below for you to check out. Finally, gaming is the last step to our stability test. We are running the benchmark in Rise of the Tomb Raider here on Ultra 1080p. While we speak about benchmarking with gaming, optimizing your game settings is essential to have realistic results. As you can see, with optimization and undervolt, our GPU temperature is maintained under 50 degrees Celsius throughout the benchmark. You may use either the easy optimization method within the NVIDIA GeForce Experience program, or another way is matching your game refresh rate with the refresh rate of your monitor. In case you're wondering, I am using the Asus VG248QG, which is a 24-inch 1080p 165Hz monitor. As I'm not a heavy FPS gamer, so I don't see the difference, I'm running it at 120Hz, and that saves on unnecessary power usage and also promotes longevity for your components. Minecraft is one of those games which you can set unlimited FPS. Notice the differences in performance between locking the FPS to 120 frames versus unlimited frames. Sure, your system will be able to run it, but with optimization, you reduce the unnecessary strain on your system. The next game we are further testing our 3080 with is Portal with RTX. It is only for RTX cards only, and you can see that the card works at 100% throughout the game. Even with a 3080, we struggle to hit 70 FPS at 1080p ultra quality. The final game in this video is the Shadow of the Tomb Raider, which, like the Rise of the Tomb Raider, it has a built-in benchmark. This game was also one of the first RTX-enabled games back in 2019. Despite having stunning in-game graphics and cutscenes, it was known to have poor game optimization, which still exists in 2023. especially within the fast travel map, which you can see both the CPU and GPU working really hard panning the 2D map. I hope this video was useful and I thank you for watching.